Let's flip the track with the old school vibe. This is how we do it.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are now giving the solution to exam jam number 10. And they just love the old Ferris wheel, don't they? Yes, they do. All right, let's get to it. Not as bad as it looks. B's a little challenging, I'll give you that. But everything else, not so bad. Okay. So we have a Ferris wheel. The wheel of the radius is 50. I'm going to put 50 here just for kicks. And it rotates clockwise at a rate of 1 revolution every 30 minutes. So that immediately tells me that the period is equal to 30 minutes. And if I need that later, I have it because it's 1 revolution. A seat starts at the lowest point P when its height is 1 meter above the ground, indicated there. Find the height of a seat above the ground after 15 minutes. Well, it's rotating at a constant rate. And so 15 minutes, it's going to be halfway around. The radius is 50, so that's a total height of 100 from the bottom of the Ferris wheel, plus 1 more. That is 101 meters. That is a gift. Yes? Okay, so now let's try B. After 6 minutes, the seat is at point Q. Find its height above the ground at Q. So we, I think you'll agree with me, are looking for this height right here. Let's go blue. Okay, we're looking for this right here. Oh my goodness. No, I don't want that. I want a line. I don't know what's the matter with me. Okay, we're looking for this height right here. Okay. All right, and so little tricky. I won't lie, little tricky. But if I were to draw a line here, I have a right triangle, and this guy is equal to this guy. Well, so what? Well, I know from here to here is 51, right? So if I could get 51 minus from here to here, which I will call x, 51 minus x, q, or no, the height, let's see, we'll call this h, I guess. The height is equal to 51 minus x. Okay? Well, how can I find x? Well, I have x here, I have 50. If I knew one of these two angles, I would be in business. Well, I know this angle because from here to here took 6 minutes. Yes? And if that took 6 minutes, let's see, that's 6 out of 30, which is 1/5 of a rotation. Well, a total rotation is, this would be pi, and all the way around would be 2 pi. So this is 1/5 of 2 pi, which is 2 pi over 5. How about that? So I know this angle right here is 2 pi over 5. Now I can use right triangle trigonometry. I'm looking for x. I know the hypotenuse 50. That is cosine. So I know that the cosine of 2 pi over 5 is equal to adjacent x over 50. Yes. So that means that 50 times the cosine of 2 pi over 5, make sure you're in radians, is equal to x. And I will tell you that x is approximately equal to 15.5. You should actually keep this in your calculator. Whatever, I forget what it is, 15.45 ... So if I put that in for x, I get a height of 51 minus 15.45, blah, 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 which is about 35.5 meters. Okay? So you just had to draw a little bit, figure out the right triangle, figure out that, okay, this is equal to this, and everything is cool. All right, so now part C. The height of the seat above the ground after t minutes can be modeled by the function h of t equals 50 sine b times t minus c. Okay, t is the minutes plus 51, and they want us to find b and c. Well, remember, period equals 2 pi over b when b is the coefficient or out in front of the variable here. Well, we know that the period is 30 minutes, yes? So 30, yes. So 30b equals 2 pi. Divide both sides by 30. b equals 2 pi over 30, which is equal to pi over 15. Bam! So b equals 2 pi over 15. Not 2 pi, pi over 15. Okay, now they want us to find c. Well, remember, this gives the height above the ground. And we know actually too, well, we know a couple of heights, but some easier heights is when time is 0, the height above the ground is 1. And when the time is 15, the height above the ground is 101. Okay? Well, since I already know what B is, and I'm looking for C, and I have an ordered pair here, I can easily solve for C. So I know that h of 0 when t is 0 is equal to 1. So I can replace h of 0 with 1 equal to 50 sine of, I know that b is pi over 15 times 0 minus c. Where do I get the 0? Well, it's right here. It's the ordered pair. T is 0 and h is the height. T, h. Okay? Or I should say h of t. That's a little easier to understand, I think. Plus the 51. So now I have to solve for c. Okay, so as I subtract 51 from both sides, I get negative 50 equals 50 sine of pi over 15 times negative c, so negative pi over 15 c. Okay, and then divide both sides by 50, and I get negative 1 equals sine of negative pi over 15 c. Well, this is paper 2, boys and girls. Let's take advantage. I can add 1, and in fact, that's what I'm going to do. I'm going to find the 0. I'm going to add 1 to both sides and say 0 equals sine negative pi over 15, 15c plus 1. And I'm going to graph that. Sine of negative pi over 15. So go to my graph thing. And so sine negative pi over 15x. I'm going to graph it. There we go. And we already know, we know that one. We want to know the next one. So I got to find that 0. You can click and drag or just extend your window. Menu, analyze graph, find the 0. To the left of the 0, to the right, to the right, to the right, to the right. And I get C equal to 15. Which is wrong. It's wrong. I'm so sorry because you know what I did? I didn't say plus the 1. I'm sitting there thinking, what is the matter with that answer? Plus 1. All right, so let's see where that is 0. I'm so sorry about that. Menu, I was sitting there thinking about it. Menu, analyze graph. What did I do wrong? 0. Let's go here and here. And we get t equal to 7.5. Sorry for forgetting to add the 1. Hopefully you caught that right away. Okay, so c equals 7.5. Okay, so now let me get rid of all this. You know what? I don't think I need to. I'll just go in pink here. Hence, find the value of t the first time the seat is 96 meters above the ground. So I would say that 96 is equal to this guy, but I know everything. 96 is equal to 50 sine of b is pi over 15, pi over 15. I keep forgetting the 1 there. Times t minus 7.5, which we just found. Okay. Make sure you get your parentheses right here. It's going to be very, very wrong when you put it in the calculator. Plus 51. So now I'm going to graph that. Okay, I'll graph both of those. I'll graph. See, let me get rid of that one. And I'll just put the 96 in there. And obviously I'm going to have to change my scale. Oops, need to redo that. Sorry, tab. I still had sine in there. Okay, so 96, bam. Okay, obviously it's out of the window. And now I have to graph that big, giant function, which was, I forget it already. 50 sine pi over 15. So 50 sine, boom, pi over 15, another parentheses, times x minus 7.5. Then I go outside, make sure you have all that in parentheses, plus 51, bam. Okay, so let's see, it looks like it's going to happen way up there. So, and I know it's 95, so menu, window zoom, I'm going to do window settings, and my X-min, I'm fine with that. Maybe my max, I'll go to 25 just to be safe, and I'll do a scale of 5. I'm fine with my Y-min. I graphed 96, so maybe I'll go do 125 just to give myself some room. Scale of 10 should be good, and I hit OK. Nice. Okay, nice. So we have two intersections. I'm going to go back and reread the question. And it says, hence find the value of the t the first time the seat is 96 meters above the ground. So that would be right here. So all I have to do is menu, analyze graph, intersection, to the left of that, to the right, and I get 12.8. So my answer would be, let's see, 12.8 minutes. There we go. All right, so that's all we got. Hope you enjoyed it. I'm wondering if this is still how we do it. What do you think? I bet you it is. Is it how we do it? This is how we do it. Yeah. All right, so I am out.